directly to the discussion of that application of the topic linear motion. And this is a topic that is mostly tested in paper 1, mostly tested. Let's take an example of this. A bus left Mombasa and traveled towards Machakos at an average speed of 60 kilometers per hour. At an average speed of 60 kilometers per hour. So we can have our road. Let our road be like that. A bus left Mombasa. Okay, a bus left Mombasa and traveled towards Machakos. Okay, at an average speed of 60 kilometers per hour. So the bus was traveling at an average speed of 60 kilometers per hour. Okay, after 2.5 hours, a car left Mombasa. Okay, now a car left Mombasa after 2.5 hours, and after 2.5 hours, a car left Mombasa. A car left Mombasa and traveled along the same road at an average speed of 100 kilometers per hour, and travel at an average speed of 100 kilometers per hour. Okay, if the distance between Mombasa and Machakos is 500 kilometers, the total distance between Mombasa and Machakos is 500 kilometers. Determine part A, the distance of the bus from Machakos when the car took off. The distance of the bus from Machakos when the car took off. Okay? Now, this is a very, very important part. Okay? The distance from Mombasa, the distance of the bus from Mombasa, the distance of the bus from Machakos. The distance of the bus from Machakos when the car took off. Okay? So we are told now that we have a bus which traveled from Mombasa to Machakos, and then it traveled at an average speed of 60 kilometers per hour. Okay? And after 2.5 hours, we had a car which took off from Mombasa towards Machakos, and it was traveling at 100 kilometers per hour. So the first question, part A of the question, you are asked, what distance did the bus cover by the time the car is taking off? What distance has the bus covered from Machakos? So we need to know, by the time the car is starting, where is the position of the bus? And we calculate the distance of that bus from Machakos. Okay? And the total distance between Mombasa and Machakos is given as 500 kilometers. Okay? So we will be generally will be using dust. Generally we'll be using dust. That is distance is equal to speed times time. Speed is equal to distance over time, and time is equal to distance over speed. Okay, so we can start by calculating. The first thing here, we need to calculate for the distance of the bus by the time the car is taking off. Okay, so the car took off after 2.5 hours when the bus was in motion. So we need to calculate for this period of time, 2.5 hours. Okay, if the bus was traveling at 60 kilometers per hour and distance we say it is speed times time, 60 kilometers per hour, multiplied by time. Time it is 2.5 hours. Okay, we get the total distance covered within that 2.5 hours. The total distance covered within the 2.5 hours will be 150 kilometers. Will be 150 kilometers. Okay, so the distance covered. Let's say the bus now within that 2.5 hours, the bus maybe it has covered up to that level. Okay, so that distance will be 150 kilometers. But you are told the distance we measure it from Machakos. Okay, the question is the distance of the bus from Machakos when the car took off. So from Machakos, the total distance is 500. It has covered 150. What distance is it remaining from Machakos or to reach Machakos? So that will be 500 minus 150. Okay? That will give us 315 kilometers. It will be 315 kilometers. So that is part 1 of the question. Part 1 of the question. Okay, hope we are okay with that. Now we go to part 2. The distance the car traveled to catch up with the bus. The distance, by the way, part A was 2 months. 2 months. And then now part B, you are asked the distance the car traveled. The distance the car traveled to catch up with the bus. Travel to catch up with the bus. Catch up with the bus. Okay, so this is given as 4 months. 4 months. The distance the car traveled to catch up with the bus. Now, for us to calculate the distance covered for the car to catch up with the bus, we need 2 things. Okay, if you want to know when will the two given objects will meet, okay, which they are moving in different speeds, then we need to calculate for 2 things. Okay, the first thing is the distance apart. Okay, by the time the second one is starting, how far were they from each other? Okay, because of course the bus started the journey first, and then later on the car started. So by the time the car is starting, what distance were they? What distance apart were they? Okay, by the time the car is starting the journey, or how far was the car from the bus by the time they are starting the journey? Okay, so we need to calculate the distance apart first. You need to calculate. You need to know the distance. Okay, distance apart. Now in our case here, the distance apart is here. The car started the journey after 2.5 hours. And after 2.5 hours, the bus had already covered 150 kilometers. So by the time this car is starting here, already the bus had covered 150 kilometers. Already the bus had covered 150 kilometers. And that's why we say here the distance apart will be 150 kilometers. The distance apart in that case will be 150 kilometers. Okay? And then the next thing you need to have for you to calculate the time it will take for them to meet, another thing, it is the relative speed. Relative speed. You need to calculate for what we call it the relative speed. Now, relative speed We have it in two ways. When the objects are moving in the same direction, for you to get the relative speed, you subtract, you get the difference of their speed. Okay? Of course, you will take the one with the higher speed minus the one with the lower speed. Okay? If they are moving in the same direction. Okay? Either they are moving in that direction or they are moving in the other direction. As long as it is the same direction. Okay? This one is moving from Mombasa to Machakos, the bus, and the car is also moving from Mombasa to Machakos. So they are moving in the same direction. We'll subtract to get the relative speed. We'll subtract their speeds to get their relative speed. If they are moving now towards each other or against each other, for you to calculate the relative speed, you add. If they are moving in the same, if they are moving in the opposite direction or towards each other, then we add. Okay? So for our case, they are moving in the same direction, so we'll subtract here. We're going to subtract the relative speed. We take the one with the higher one minus the one with the lower one. So we'll say 100 minus 60, and that is going to give us 40 kilometers per hour. Okay? That will be the relative speed. And then after that, now we can now calculate the time taken for them to meet. Time is distance over speed. So time taken for them to meet will be the distance apart, 150 kilometers, divided by the relative speed, 40 kilometers per hour. So if you divide the two, you will get now the time it will take for them to meet. So divide by 40. You will get 3.75 hours. Okay? Or rather 3 and 3.75 hours. Okay? So whatever, you can use the decimal, you can use the fraction, there's no problem. Now, these two vehicles will take 3 hours, 3.75 hours. Okay, 3.75 hours for them to meet. After what? After the car has started the journey. This time taken for them to meet is the time the car it will take to meet with the bus. It will take a total of 3 hours, 3 and 3 over 4 hours. It will take 3 and 3 over 4 hours for it to catch up with the bus. So the question is, we are asked the distance the car traveled to catch up with the bus. So we are not asked for the time it will take, but what we have calculated is the time it will take for the car to catch up with the bus. So if it will take 3.75 hours, then what distance will it have covered by then? So we calculate the distance is equal to speed times time. Speed, the speed that the car is moving with is 100 kilometers per hour and multiplied by the time. Okay, and that is going to give us a total distance of 375 kilometers. A total of 375 kilometers. Okay, so that will be the total distance the car will cover to catch up with the bus. So the car, by the time they are now meeting. The car and the bus, it will have covered 375 kilometers. Okay, that is 4 marks. Now part B, we are through with part A. Now part B you're told this is also another 4 months. Is another 4 months. Okay? Now we're told immediately the car catch up with the bus, the car stopped for 25 minutes. Immediately the car catch up with the bus, the car stopped for 25 minutes. Find the new average speed at which the car traveled in order to reach Machakos the same time as the bus. Find the new average speed of which the car will move with to reach Machakos the same time the bus at the same time as the bus. Okay, so we said after covering 375 kilometers, they have catch up with one another. Then the car stopped for how many hours? Stopped for 25 minutes. 25 minutes. The car stopped for 25 minutes. Okay? So as the car stopped, remember, the bus is continuing with the journey. Okay? When they have now catch up, then the car stopped, the bus continues with the journey. And the car stopped for 25 minutes, but now we're told calculate what speed will the car move with to reach Machakos the same time as the bus. Okay? So we need to know here that from where they have met, what time did it take for the bus to reach Machakos? That is the first thing. From the time they have met, what time will the bus take to reach Machakos? So they stopped, they met at 375 kilometers. The total distance is 500 kilometers. So what distance is remaining there? The distance that is remaining, we'll say first, we'll take 500 kilometers minus 375 kilometers. And that is going to be equal to what? It is going to be equal to 125 kilometers. So this will be the total distance that is remaining. The total distance that is remaining, we'll say it is 125. 125. Okay? So 125 kilometers. And the bus is moving at what speed? It is moving at a speed of 60 kilometers per hour. So what time will it take? Time taken. Time will say it is equal to it is going to be equal to distance, which is 125, divided by speed, which is 60 kilometers per hour. So from there we can get the time it will take for them to meet. That is 120, the time it will take for it to reach Machakos. 125 divided by, that is going to be 2, yes? That is going to be 2 and 1 over 12 hours. Okay? It will take 2 and 1 over 12 hours. Okay? 2 and 1 over 12 hours. 2 and 1 over 12 hours. If you change that into minutes, you can change that into minutes. You multiply by 60. Okay? That's 1 over 12. You can multiply by 60 to change it into minutes. So it will take a total time of 2 hours and 5 minutes. It will take 2 hours and 5 minutes. So the bus will take 2 hours and 5 minutes to reach Machakos from where they have met. Now, if it is the car to reach Machakos the same time as the bus, it means First, they can't stop for 25 minutes. So we have to subtract those 25 minutes the car stopped and see what time will it, what duration now will be remaining. And the car will have to use the remaining time, okay, to move with higher speed to reach Machakos at the same time as the bus. Okay, so I hope we are communicating here. Are we communicating? Others are mute. Okay, so now we are saying we need to subtract it. It will be 5 minus 5 is 0. And then we borrow 1 from the other side, it will be 6. So it will be 6. 6 minus 2 is going to be 4. Okay, and here we will be 1. So 1 hour 40 minutes. So the car is already used 25 minutes for its relaxation, and then now it will be remaining with 1 hour 40 minutes. If it is to reach Machakos the same time as the bus, because the bus took 2 hours and 5 minutes, okay, and the car stopped for 25 minutes, so it will be remaining with 1 hour 40 minutes. Okay, we can change that 1 hour and 40 minutes into hours. It will be the same as 1 hour 40 divided by 6. 40 divided by 6. Okay, so 1, 0, 0 goes by 2, 2 by 2, 3. It will be 1 and 2 over 3 hours. So the car has to use 1 and 2 over 3 hours, and the distance is the same. Distance is 125 kilometers. The distance that is remaining is 125 kilometers. So from there now we can know the speed that the car will move with. We can calculate now the speed the car will move with to reach Machakos the same time as the bus. So speed is equal to the distance to be covered, which is 125 kilometers. Divide by 1 and 2 over 3 hours. Okay? That will be equal to what? That is, we are calculating them. So 125 divided by 1 and 2 over 3. So that will be 75. It will give us 75. 75 kilometers per hour. So the bus has to go at a speed of 75 kilometers per hour. Sorry, not the bus, but the car. The car has to travel at a speed of 75 kilometers per hour for it to reach Machakos the same time as the bus. Okay. Now these questions are commonly tested. Okay, of which you need to master the concept. You need to master the concept very well. Okay. Now very fast, I think we can cover another question very fast. Okay. So since now you already know the concept, I will not explain a lot. We'll just go directly into calculations. Okay. Okay. Now we have this question. You're told The distance between two towns A and B is 460 kilometers. The distance between two towns A and B is 460 kilometers. 460 kilometers. A minibus left town A at 7:15. Minibus left town A, of course, towards town B at 7:15 a.m. Okay, a minibus left town A at 7:15 a.m. and traveled towards B at an average speed of 60 kilometers per hour. 60 kilometers per hour. Sorry, 65. Travel at a speed of 65 kilometers per hour. A car left town B. A car left town B. A car left town B at 9:15. At 9:15 a.m. on the same day and traveled towards town A at an average speed of 100 kilometers per hour. 100 kilometers per hour. Part A. How far from B did they meet? How far from B did they meet? That's part A. How far from B did they meet? From B did they meet? Now, that is 4 months. How far from B did they meet? Now, always when we're talking about meeting, when we're discussing about meeting, then you should have in mind those two things. We said distance apart. You must know the distance apart, and also you have to know the relative speed. Always when you're discussing about meeting, okay, two objects with a different speed to meet, then we must know the distance apart and the relative speed. Distance apart is, this one started the journey at 7:15 a.m. and the other one started at 9:15 a.m. So by the time this one is starting at 9:15 a.m., this minibus had already covered a certain distance. Okay? And that distance which it has covered, now that will be the one which we can use to know how far were they from each other. By the time the car is starting, how far was it from the minibus? Okay? So we need to calculate the time between 7:15 to 9:15. Okay, this will be 2 hours. The time will be 2 hours here. 9:15 and what? 7:15. You subtract there 0, that will be 2. So it will be 2 hours. Okay, so what distance will the minibus cover within these 2 hours? Okay, so we'll say distance, the minibus will cover within those 2 hours will be the speed, which is 65 times the time taken, which is 2 hours. Okay, so this will be a total of 130 kilometers. 130 kilometers. So the total distance covered, will be 130 kilometers. 130 kilometers. So now it has covered 130 kilometers. Maybe it was going to be somewhere there. Okay? So how far apart, how far were they from each other? Will be the total distance, which is 460 minus 130 for us to know the distance apart. okay, which will be 100, which will be 330 kilometers. So these people or these two bodies were 330 kilometers apart. So 330 kilometers apart. So the distance apart is 330 kilometers. Okay? The relative speed, we have to add the two speed now because they are moving towards each other. Therefore, we are supposed to add. We'll say 65 plus 100, and that will be 165 kilometers per hour. Okay, so if we have the two, then we can calculate the time it will take for them to meet. So time will be the distance covered, 330, distance apart over relative speed. So 330 divided by 165. 330 divided by 165. So that is going to be 2 hours. 2 hours. So it will take 2 hours for them to meet. 2 hours from the last person, yeah, to leave. So it will take the car 2 hours for it to meet with the minibus. So what is the question? How far from B did they meet? How far from B? How far from B did they meet? So we can just calculate from B is where the car is coming from. So we can calculate the distance from B, the distance covered by the car by the time they will meet. Okay, so the distance covered by the car, we say is going to be speed 100 kilometers per hour times 2 hours, so it will be 200 kilometers. 200 kilometers. And since the car is moving towards this side, that will be the distance covered from B to where they will meet. They will meet there, then the distance covered from B will be 200 kilometers. 200 kilometers. So the distance covered, how far from B did they meet, will be 200 kilometers. There were 200 kilometers from B, from the point of meeting. Okay. Part B of the question, that was 4 marks. Part B, you told at what time the two vehicles met. At what time? Now, at what time? So, what exact time did they meet? What exact time did they meet? Okay. So, at what time it will be this one, 9:15 a.m. We need to add 2 hours. It took 2 hours for the car to meet with the bus. So plus 2 hours. So that will be 11:15 a.m. So they will meet at exactly 11:15 a.m. They will meet at exactly 11:15 a.m. So I can finalize with the part C now. Finalize with part C. A motorist started from his home. A motorist started from his home at 8:15. Okay, now there is a motorist. Motorist started his journey from his home at 8:15 a.m. on the same day and traveled towards B. So it was traveling, this bike was traveling towards B, from home towards B. At a speed of travel, so it was heading to B and it was moving at a speed of 120 kilometers per hour. He arrived at the same time as the minibus. The minibus, remember, started its journey from A going to town B, but it reached the same time. The motorist who started the journey at 8:15 a.m. and what was traveling at 120 kilometers per hour reached town B the same time as the minibus. Calculate the distance from B to his home. Calculate the distance from B to his home. Okay? So the first thing we need to know is what time did the minibus reach town B? That's very, very important. So the total distance to be covered there, it is time. The total distance is 460 kilometers. The speed is moving with is 65 kilometers per hour. So we can calculate the time it will take to reach there. 460 divided by 65. It will take 7 hours, 7 and 13, 7 and 1 over 13 hours to reach there, which is the same as 7 hours and how many minutes? And how many minutes? You take 1 over 13 multiplied by 60. It is going to be 4.515. So if you round up that to the nearest minute, it will be 7 hours and 5 minutes. 5 minutes. So if it started the journey at 7:15, okay, so what time will it reach town B? So plus 7:15. So this will be 10 2. Okay, and that 7 is 14. So it will reach 1420 hours. 1420 hours, which is the same as 2:20 p.m. 2:20 p.m. Okay, so I can mark this side. Now that motorist started the journey at 8:15, but reached the same time as it reached town B the same time as what? The bus. So let's check how long did it take. 1420 and minus 1815. Let's check how long did it take to travel. So this will be 5 minutes